Hello and welcome to the Access Control Coaching Session. I'm your host, Cole Nebaker, and I am the Training and Events Manager for PDK. Today, we're going to be talking about wiring, the fundamentals of access control wiring. This is going to include everything from readers to locking hardware to peripherals and the type of wire that we use. This is going to be a bit of a crash course, and it is going to go fast. So if you have any questions, be sure to leave them in the comments and be sure to subscribe, as we will have more content on the channel. So without further ado, let's dive in. We're going to start with line loss. What we have with line loss is dependent on the gauge of the wire. Most commonly, what I've worked with installers in the field is 18 to 22 gauge wire. Now, which gauge you use is dependent on the voltage that you're using, the amperage needs, and the distance. So these wiring needs can be dependent on the voltage and the amperage. As you can see from this chart here, we have got 12 versus 24 volt. Now, it's important to keep in mind that for PDK, we only output 12 volts. So if you are going to do 24 volt locking hardware, you will need to look at an external power supply. But let's take a very standard application here. We've got a 300-foot run with let's go with a 600 milliamp mag lock. We're looking at 16 gauge wire for the 12 volt application and 18 gauge wire for the 24 volt. So you can see a slight difference in the gauge of wire that you use. But again, you can make these calculations very easily. Now, if we go to the next slide, we need to talk about the communication method. This is either going to be with PDK, the Ethernet, the PoE, or the wireless, the WiMAC that we offer. Keep in mind that with cat cabling, you have a maximum distance of 100 meters, or since we're American, 328 feet. Keep in mind, do not ever use cat cabling for your readers, your peripherals, or your locking hardware. You will always use stranded wire for that 18 to 22 gauge. All right, now our reader wire is typically going to be either 18 gauge or 22 gauge, and the distance is dependent on the communication protocol and the size of the wire. So we will be using anywhere from 4 to 8 conductor wires for a reader application or a reader wiring. Of course, everyone will have the DC and the ground, the red and the black, and all of them will have the data 0 and the data 1. If you are doing OSDP, that's it. You have 4 wires that you will be using. If you do Wiegand, specifically with PDK, you will be using 5 wires or 6 if you choose to control the piezo. That will control the LED and the piezo respectively. So it could be anywhere from 4 to 6 wires with PDK, but it could potentially with other access control manufacturers be all the way up to 8 wires that you need for the reader. And again, 18 or 22 gauge wire, stranded, shielded preferable. For our lock and our DPS wire, as a general rule of thumb, I would go with 18 gauge stranded wire. The reason being is you could technically get away with 22 wire for like the DPS and potentially for some door strikes, but I think it's just beneficial to play it safe sometimes. So if you do need a general rule of thumb, I'd go with 18-2 stranded wire. Your line loss distance on average will be about 350 feet. You do have things like banana cable, which allow you to run everything through a single line. You've got your lock power, which could be either an 18-2 or an 18-4. You've got your door contact, which in this case shows a 22-2. Again, you could do an 18-2 if you want to play it safe. A request to exit, which will be a 22-4, and then your reader, which will either be a 22-4, a 22-6, an 18-4, an 18-6. Again, just dependent on the distances that you are running. All right, your mag lock is going to be installed on the secure side of the door, and we're going to get into some of the wiring diagrams of these locking hardwares. So wiring a strike, starting with the strike, you are going to wire it into the positive and the normally open of the PDK board. The reason I say the normally open instead of the normally closed is that most frequently strikes are fail secure. They have some kind of crash bar, physical egress. Be sure to install your diode. That gray side of the diode does go on the positive of the strike. And then if you are providing power through the PDK board, be sure to put your jumper on negative and bus, or positive and bus if you are using the negative of the reader ports or the negative of the power input, as opposed to the instead of the positive. Okay, so what I've got here is a wired up door strike. So we've got our PDK red 1 right here. We've got our door strike right here, and it just has 2 wires. One is run into the positive of the reader ports. Alternatively, you could put it into the positive of the input power. And we've got the other side going into the normally open. And I'm going to try to provide some contrast here. We've got a jumper that is on the negative and bus pins of the PDK board. This means that we do have a ground through the relay. Whenever the relay is activated, it provides a loop and it unlocks the electric strike. Now, another kind of peripheral that you may be using frequently would be the door position sensor. The door position sensor is there to tell you if a door is open or closed. We encourage everybody to use a door position sensor. It is cheap and very easy to install. Again, 22.2 or 18.2 stranded wire. We've got 2 kinds. We've got the recess mount, which is typically done by drilling into the door and the door frame, inserting them, and then they mount flush. And when the door is closed, the magnet is picked up by the sensor, and the sensor determines that the door is closed. The other kind would be a surface mount. It's perhaps a little more visible to the eye, but performs the exact same thing. Wiring these is very simple. We are going to wire them into the A and negative, or if we're doing a double DPS contact, we can wire them in series with each other so that both have to be closed before they are detected. They are simply wired into the A and negative. So on our model here, you can see that this DPS is a surface mount, kind of ugly, not quite as attractive as the recessed, but gets the job done. We have got the magnet right here, and we've got the sensor right here with the 2 wires leading out of it. These 2 wires come into the PDK board into the A and ground, the A and negative. We do have an A, a B, and a negative input on this block right here in the middle, if you can see it. No jumpers are necessary because we are not controlling anything on the relay. All right, now moving on to the readers. The readers are going to be wired in one of 2 ways with PDK. They're either going to be Wiegand or OSDP. There is a third option on here called clock and data. That is another kind of communication protocol between the reader and the controller. Wiegand, I'm sure you are all familiar with. It transmits simple binary from the reader to the controller through the data 0 and data 1. OSDP is the new standard Open Supervised Device Protocol set forth by SIA. And it is a more secure protocol. And because of this, it is a 2-way communication and it is encrypted. So we always encourage individuals to use OSDP where possible. Wiegand has a communication distance of 500 feet, whereas OSDP has a communication distance of up to 4,000 feet. Of course, you would need to make sure the wiring is compatible for that. So when we are wiring a reader, we've got the 2 methods here. We've got Wiegand, which is the one wired directly into that reader on the screen. We've got positive, negative, 0, 1, and L, and that L stands for LED. The B down there stands for buzzer. So if we're wiring Wiegand, it will be red, black, green, white, brown, or blue. That brown can be interchangeable with blue, dependent on the reader. If we're doing OSDP, it's a little bit simpler. All we need is red, black, white, and green, just those 4 connectors. Now, OSDP wiring is a stranded twisted pair. Different sizes of wire depending on who you ask, but 22 gauge and 18 gauge for longer distances should more than suffice. Now you notice up at the top there we've got the OSDP pins. You'll want to be sure if you are wiring OSDP to put a jumper on those pins. So we have got a reader wired in right here. You can see I've got the red, black, white, and green plugged into the reader block. I have left that L empty. And I do have a drain wire right here because this is shielded. Now, again, I'm going to try to show the jumper here. This is plugged into these jumper pins about 3/4 of the way up in the middle of the board. I know it kind of blends in, the black on black. But you will want to always be sure to put your OSDP pin in there if the OSDP is end of line. All right, now, finally we have got our Rex. So the Rex is going to be the device that releases the door, either when a button is pushed or motion is detected. These are frequently used with mag locks. The mag lock will typically, depending on your state, need to be wired in series with the Rex. The reason for this is because you cannot have a software program that is releasing the door. It will need to be wired in series, and sometimes you do need two forms of egress. So definitely be sure to pay attention to this diagram. We've got our mag lock there on the right, wired in positive and negative. And again, this is the assumption that this is a 12-volt mag lock being powered directly off of PDK's board. If it is a 24-volt mag lock, you will need to wire this through a third-party power supply. So we have got the negative of the mag lock tied into the normally closed of the Rex. This means that when the Rex is not activated, power is being provided to the mag lock. When the Rex is activated, it switches over to the normally open, which is tied into the B input. So you can see we're kind of killing two birds with one stone. We've got the B tied into the normally open of the Rex and the normally closed of the Rex tied into the negative of the mag lock. And this creates one seamless loop that both controls our mag lock and reports on it. And again, if you are using PDK's power, you will need the jumper on the negative and bus on the PDK board. So you can see here, we don't have a mag lock. Unfortunately, they're a little too bulky to fit on this can. But we do have a motion Rex, a pretty standard one. So we've got 4 wires here. We've got the positive and negative providing the power to the Rex, and we have got the B and negative. So this is tied into the relay of the Rex and is reporting on the stat of the motion detected at the door. So all we need to do is tie it into the common and B on this second block, which is the same block that we tied the DPSs into. And now whenever this relay trips, it will report here, and we can program in the software, for example, to say open and close that door when this detects input. All right, so we've talked a lot about the 12 versus 24 volt hardware. There are advantages to both. If you're doing 12 volts DC, it is going to be a larger gauge wire because it may be more prone to line loss. It will be slightly shorter distances, so it really depends on whether you're centralizing everything or maybe doing edge devices of some kind, and it will provide more heat. Now, one of the advantages is that you only need one battery. You're certainly welcome to do more than one battery, but you only need one. Those 12 volt, we can fit up to 12 volt 8 amp hour batteries in our enclosures. If we go to the amperage calculations, we will need to be able to calculate what kind of power draw we're going to pull. So the way we do this is we go to all of our devices and we calculate the maximum amperage draw of each. Readers have them, Rexes can have them, locking hardware certainly has them. And then your PDK boards, not going to pull much, but we can factor it in. It takes about 40 milliamps of continuous current to keep a PDK board running. So when we add those all together, we just need to make sure that if we are powering through PDK boards that we have no more than 1 amp per port. This includes the reader, the DPS and Rex input, and the locking device. As long as we stay within 1 amp, we should be good. Don't forget to count your inrush. This is probably not going to be much of an issue unless you are using electrified crash bars. Those can sometimes have very significant inrush. Your standard door strike and maglock will be just a handful of milliamps. Dependent on range, you may also need to consider the voltage range, or I should say the distance. Dependent on distance, you need to be conscientious of your voltage range. Some things do have a little bit of tolerance, but if they don't, you need to make sure you push enough power to get all the way out to the device. So you can see here an example of the inrush current. These are just imaginary numbers, but we'll say, for example, we have an inrush current of 0.5 amp, and we have the continuous amperage of maybe 40 amps. It'll be pretty negligible, but that's the idea behind inrush. Now, battery-wise, we need to make sure we have enough amperage to control all of our stuff. We will need to make sure that we have enough for inrush as well. Now, the nice thing is one of our integration partners, Altronics, has some publicly available calculators that will assist us with calculating the lifespan of the battery, how long it will keep all of our stuff up and running dependent on the amperage draw. So if we do need to add additional batteries, we can either wire in parallel or we can wire in series. If we wire in parallel, the voltage stays the same, which would probably be the optimal setup for PDK because we take a 12-volt battery input. But the example here is that we have a 12-volt 100 amp hour battery times 2. It now becomes 12 volts and 200 amp hours. If we run in series, we would take 2 12-volt batteries and create a single unified 24-volt battery with 100 amp hours. And finally, once we get all of this situated, we power it all on. You can see there we've got a 12-volt, 8 amp hour battery tied into our red one on the screen. And then we can put 12 volts into our board. Again, we do provide the power supplies for these controllers. We have a little transformer that we include with each of them. If you have a red 1 or a red 2, you have 14 volts and 2 amps to work with. If you have a red 4 or an A8, you have got 12 volts and 5 amps to work with. And if you have a red 8, you will have 12 volts, 10 amps. And if you have a red max, you will have 12 volts and 20 amps to work with. So there you have it, the crash course. If you guys do have any questions, be sure to leave them in the comments, and I'm actually going to read those right now. Okay. Who calls the non-jackets composite cable candy cane instead of banana? That's actually the first that I've heard of that one. I've only ever known it by banana, the yellow exterior. Is there a practical difference for the board using positive versus negative? No, not really. I've just always grown accustomed to using the negative on the relay as opposed to the positive, but you could use either one. I think when you're wiring it through a third-party power supply, it's especially advantageous to tie the negative, the common, through the relay. But is there any chance of allowing for supervised contacts? Yes. You'll want to keep them separate. I'm not sure the exact reasoning behind this. I've followed a few threads in some access control forums. My understanding is that supervised contacts versus door position sensors will sometimes cause an issue between the two of them. I don't know if this is due to voltage feedback or maybe just some kind of incompatibility, not 100% sure. You'll want to keep them separate. The door position sensor to the access control system and the intrusion detection for the intrusion system. At one point, the documentation said you only need an OSDP jumper if you have multiple devices. Is that still true? just add it to everything. It's technically every end-of-line device, so it's especially applicable with those multiple readers if you're doing multi-drop. But for practical terms, just be sure to put that OSDP pin on always. Better safe than sorry. Coolest power integration I used was PDK with Altronics Trove. I agree. Some states do require blanking. Okay, I think that is all of the questions. If you guys do have any other questions, be sure to reach out to the sales team. They're phenomenal. That's a hard word. It is sales, plural, at prodadakey.com. They're very knowledgeable, and they'll be able to help you, especially with site design, if you want to work with them on distances and common applications of what they've seen. They're great. All right. So I guess that covers it. Again, reach out to the sales team if you have any questions, but we'll catch you at the next Access Control coaching session.